Hello, and welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl, and in this episode, we're taking a look at what's happening in the December 2025 skies. And there's a lot happening. Winter is here this month, and with it comes cold weather and long, dark nights that make for excellent observing conditions. We'll check in on the planets, highlight a meteor shower, give a comet update along with other space news, and then we'll explore a lunar lava plain. And lastly, we'll wrap up with a tour of the constellation Taurus the Bull. Please remember to like and subscribe. It helps us to let others know just how wonderful astronomy is. Okay, enough of my yapping. Let's settle in and get started with this month's Planetary Roundup. As December gets underway, Mercury is putting on a respectable show for early morning observers with a clear view toward the southeast. On the first of the month, it rises at 5:22 a.m., and by 6 a.m., it climbs to more than 6 degrees above the horizon, shining at magnitude 0. Through a telescope, Mercury presents a small crescent, just over 7 arcseconds across. You won't see much in the way of surface detail, but catching the planet in a defined phase is always rewarding. The best morning to track it down will be on December 5th, though Mercury remains an easy target for the first couple of weeks this month. After that, it sinks lower each day, and by year's end, it becomes a challenge in the increasingly bright morning twilight. As December begins, early morning risers with a clear eastern horizon may catch a brief glimpse of Venus, which rises only about 45 minutes before the sun. On the 1st, Venus shines at magnitude minus 3.9, but it sits less than 9 degrees from the sun, making it tough to pull out of the brightening twilight. As the month progresses, the separation tightens to around 3 degrees, so Venus quickly becomes nearly impossible to spot until it swings into the evening sky later in late February of 2026. Mars is completely lost in the sun's glare this month and won't reemerge until it begins climbing back into the morning skies in the spring. Jupiter is putting on an excellent show this month, and that continues right into the new year. As December opens, Jupiter rises at 5:37 p.m. and shines brilliantly at magnitude minus 2.5. Its disk spans just over 44 arcseconds, and it reaches its highest point in the sky, crossing the meridian, just after 3 a.m. By the end of the month, Jupiter rises a little earlier at 5:24 p.m. and transits shortly before 1 a.m. It brightens to magnitude minus 2.67 and expands to nearly 47 arcseconds across. Next month, the planet will reach opposition and will be at its very best for the year. Even in binoculars, Jupiter looks impressive. You can see its disk, and you may catch the 2 dark equatorial bands, along with the 4 Galilean moons. Through a telescope, Jupiter is simply spectacular. Smaller scopes reveal multiple cloud bands and the Great Red Spot when it's facing us. With 6-inch and larger instruments, look for finer details like storms, eddies, and delicate structures between the belts. There are also a couple of nice pairings with the moon. On the evening of December 6th, the 93% illuminated waning gibbous moon sits about 9 degrees above Jupiter in the eastern sky. On the 7th, the 86% moon appears roughly 7 degrees to the left and slightly below the planet. And on December 30th, observers along the U.S. East Coast get a great treat, a Ganymede transit. Viewers farther west will also be able to see it, but those on the West Coast will miss out, as the event takes place during daylight there. On the East Coast at around 6 p.m., the moon's shadow appears just below Jupiter's southern equatorial belt. Over the next couple of hours, both the shadow and Ganymede march across the planet's disk. The shadow finishes its transit around 8:20 p.m., and Ganymede completes its own crossing a little over an hour later. It should be a fun one to watch. Saturn is well placed in the southeast as darkness falls on December 1st. It glows at magnitude 0.9 in Aquarius, transits the meridian at 6:58 p.m., and sets just before 1 a.m. The planet itself spans about 18 arcseconds, but when you include the rings, the system stretches to nearly 42 arcseconds across. By the end of the year, Saturn transits just after 5 p.m. and sets at 10:54 p.m. It fades slightly to magnitude 1 and shrinks by about an arcsecond compared with the start of the month. The rings are nearly edge-on from our point of view, giving Saturn a very different appearance than most observers are used to. Over the next several years, they'll gradually open back up. In binoculars, the rings are challenging to pick out because they're so thin and the planet's so bright. Through a telescope, though, you should be able to see the rings clearly, along with some banding and subtle details across the disk. On the evening of December 26th, the 6-day-old waxing crescent moon will sit about 3 degrees to the right of Saturn. It should make for a beautiful pairing, easily enjoyed with the naked eye or through binoculars. As December begins, Uranus glows dimly at magnitude 5.6, putting it right on the edge of naked eye visibility from a dark site. It's easy to track down this month, sitting about 4 degrees south of the Pleiades in Taurus. Having reached opposition last month, Uranus is still near its best, spanning about 3.8 arcseconds across and crossing the meridian just before 11 p.m. By the end of the month, Uranus transits a little earlier, just before 9 p.m., and sets around 4:12 a.m. Its size and brightness remain essentially unchanged. In binoculars, Uranus shows up as a pale, bluish-green, slightly bloated star. Through a telescope at higher magnification, you'll be able to resolve its tiny disk. Although Neptune is even fainter at magnitude 7.7 and spans only about 2.3 arcseconds, it's conveniently placed near Saturn all month, which makes it much easier to track down. On December 1st, Neptune sits a little more than 4 degrees east-northeast of Saturn, and by the end of the month, that gap narrows to just over 3 degrees. So when you're out observing Saturn, be sure to take a moment and try to spot Neptune as well. As I'm recording this episode, Comet Lemmon is still out there glowing at around magnitude 6 and sporting a small tail. It can be seen in binoculars, but it's low in the west at sunset and is becoming harder to spot. Comet C2025K1 Atlas appears to have fragmented into several pieces. It's glowing around 9th magnitude and looks like several comets next to each other. This one will begin to fade quickly, so try to spot it while you can. Another comet making headlines this month is Comet 3I Atlas, and this one is truly special, as it's only the third confirmed interstellar object ever seen passing through our solar system. That said, there's been a lot of clickbait and conspiracy around it. Some people are claiming it's an alien spacecraft, while others are warning of an impending collision with Earth. Despite all that noise, repeated observations strongly back up the simpler and more scientifically grounded truth. It's just a comet. A really interesting one, yes, but it's not a threat. Here's what we actually know about it. Comet 3I Atlas was discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile. Its path is hyperbolic, which means it's not gravitationally bound to the Sun. It's just passing through our solar system. Based on multiple observations by the Hubble Space Telescope, its nucleus is determined to be somewhere between 440 meters, or around 1,400 feet, and 5.6 kilometers, or around 3.5 miles across, making it around the average size of comets that we've observed. Now this thing is moving fast. At discovery, it was traveling at about 137,000 miles, or 221,000 kilometers per hour, and at perihelion, its closest point to the Sun, that speed increased to around 153,000, or 246 kilometers per hour. 3I Atlas will make its closest approach to the Sun, known as perihelion, at a distance of around 1.4 astronomical units, or 130 million miles, placing it just inside Mars's orbit. It will be closest to the Earth, about 1.8 AU, or roughly 170 million miles, or about 270 million kilometers from us, on December 19th. Scientists are very clear about this. There is no danger to Earth from this comet. Observations show a coma, a cloud of gas and dust, typical of a comet. Polarimetric studies, which look at how light scatters off a comet, reveal some very unusual behavior. 3I Atlas displays negative polarization at very small phase angles, but nothing definitively alien. Additionally, as it moved toward the Sun, its brightness and color changed in a way that suggests evolving emissions of dust and ice. Of course, because it's interstellar, it's of huge interest. Observatories, Earth and space-based, are actively tracking it, not because it's going to hit us, but because it's a rare chance to study material from outside of our solar system. As December begins, Comet 3I Atlas is rising in the early morning hours, around 1 a.m., and can be found in the constellation Virgo, near the star Beta Virginis. Right now, the comet is roughly at magnitude 11, which means it's well within reach of modest telescopes, though you'll need a reasonably dark sky to spot it. While it may brighten slightly, this is going to remain a purely telescopic object to spot. December gives meteor watchers 2 chances to spot shooting stars. The Geminids are considered the best meteor shower of the year, and for good reason. This shower produces up to 120 meteors per hour at its peak. The shower comes from the debris left behind by the asteroid 3200 Phaethon, which was discovered back in 1982. The Geminids are visible from December 7th through the 17th, and this year they peak on the night of December 13th, going into the morning of the 14th. The last quarter moon will wash out some of the faint meteors, but the Geminids are so active that we should still get a solid display. For the best view, head to a dark site after midnight. Make sure to dress warmly in layers. Bring a comfortable chair or blanket, and give yourself time to get dark adapted to best enjoy the show. The meteors will seem to radiate from Gemini, but as always, you can spot them anywhere in the sky. The second shower in December is the Ursid meteor shower, a minor shower that can produce as many as 5 to 10 meteors per hour. The meteoroids are particles left behind from periodic comet Tuttle. However, you'll want to be in dark skies to have the best chances of spotting this shower. The peak falls on the 21st going into the 22nd, so the moon will be a thin crescent that sets early in the evening and won't interfere with the meteor shower. In astronomy news, NASA's twin ESCAPADE spacecraft launched on November 13th aboard Blue Origin's New Glenn rocket. The 2 craft are now on their way to study how the solar wind interacts with the Martian atmosphere. What makes this mission particularly interesting is its unusual flight path. Instead of heading straight for Mars, the pair will first settle into a staging orbit near the Sun-Earth L2 Lagrange point. They'll remain there until late 2026, when the next Mars transfer window opens, and then begin their journey to the Red Planet. This launch was notable for another reason too. It marks the first time a private aerospace company other than SpaceX has successfully landed a booster on an ocean barge after an orbital mission. Congratulations to Blue Origin on this milestone. It's great to see more players advancing what's possible in commercial spaceflight. Japan's Akatsuki spacecraft, also known as the Venus Climate Orbiter, had one of the most dramatic stories of any planetary mission. Launched in 2010 to study Venus's atmosphere, it failed its first attempt to enter orbit and spent 5 years looping around the Sun. In 2015, engineers pulled off an impressive recovery, using only the probe's attitude control thrusters to guide it into a very different, highly elliptical Venusian orbit. From there, Akatsuki became Japan's first successful Venus orbiter, and spent the next decade studying the planet's thick, fast-moving atmosphere. Using 5 cameras that observed in infrared, visible, and ultraviolet light, the spacecraft explored Venus's cloud layers, atmospheric circulation, and even spotted what appeared to be a massive gravity wave high in the atmosphere, an intriguing clue as to how Venus's superrotation works. Akatsuki searched for lightning, signs of active volcanism, and other atmospheric mysteries while operating far beyond its original 2-year mission plan. Its improvised orbit was much larger and slower than intended, taking 10 days instead of the planned 30 hours, but the spacecraft continued to return valuable science for nearly a decade. On October 28th of this year, JAXA declared that the spacecraft was not responding and officially ended the mission. Even with its rocky start, Akatsuki delivered an impressive scientific return and remains one of the most remarkable comeback stories in planetary exploration. Now it's time for the
Lunar Feature of the Month.
This month we're heading to one of the moon's most beautiful showpieces, Sinus Iridum, which is known as the Bay of Rainbows. This sweeping crescent-shaped plain of ancient basalt forms the northwestern extension of Mare Imbrium, and it's framed beautifully by the rugged Montes Jura range. At either end of that arc, you'll find two striking headlands, Promontorium Heraclides to the southwest, and Promontorium Laplace to the northeast, which give the bay its distinctive shape. Sinus Iridum is actually the remains of a massive impact crater whose walls were overtopped long ago by lava, leaving behind a broad, smooth floor accented by subtle, wrinkled ridges. While the bay itself is relatively free of major craters, you can spot Heraclides E, Laplace A, and Bianchini G tucked around its edges. The whole region spans about 249 kilometers and sits at 45 degrees north, 32 degrees west, and has long been considered one of the most beautiful sights on the lunar surface. In fact, it was once the planned landing site for China's Chang'e 3 mission, which landed in nearby Mare Imbrium in 2013. If you time your observing just right, about 10 or 11 days after new moon, you can catch the famous golden handle effect, when the Montes Jura are lit by sunlight, while Sinus Iridum itself remains in shadow. It's a stunning sight and a favorite target for lunar observers. I hope that you'll explore this stunning lunar feature the next time that you're out looking at the moon. Now let's go out of the solar system and take a deep sky tour of the constellation Taurus the Bull. This large constellation spans around 45 degrees of sky and is near the celestial equator, making it visible in both the northern and southern hemispheres. The constellation is home to some of the most well-known stars and deep sky objects that we can see. The constellation is low in the east at sunset this month, but climbs higher in the sky as the nights progress, making for excellent viewing in December. The brightest star in Taurus is Aldebaran, glowing at magnitude 0.85. It's one of those stars that instantly grabs your attention. It burns with a warm, steady orange glow that stands out beautifully on crisp winter nights. Even though it appears to sit right in the middle of the Hyades cluster, Aldebaran isn't actually part of that group at all. It's much closer to us, only about 65 light-years away. What we're seeing is perfect line-of-sight coincidence. This lone foreground star just happens to lie between us and the V-shaped Hyades, making the whole region one of the most recognizable patterns in the sky. What makes Aldebaran particularly interesting is what's happening inside of it. The star is a red giant, meaning that it's exhausted its hydrogen in its core and has expanded to about 45 times the diameter of our Sun. Despite having a cooler surface temperature, it shines hundreds of times more brightly, simply because of its enormous size. It also shows slight, irregular variations in brightness, subtle enough that most observers never notice, but real nonetheless. And if you want a reliable way to track it down, just follow the line of Orion's belt up and to the right. The path leads you straight to Aldebaran, to the Follower, a name it earned long ago because it seems to trail behind the Pleiades as they climb the sky. Now let's dive into some of the deep sky gems that Taurus has to offer. First, let's visit one of the most iconic clusters in the winter sky, M45, better known as the Pleiades, Subaru, or the Seven Sisters. This open cluster sits in the constellation Taurus about 444 light-years away from us, at a magnitude of 1.6 and spanning almost 2 degrees of sky. It's easily visible to the naked eye, even from suburban skies. The Pleiades are dominated by hot, luminous B-type stars, and its brightest members form that famous dipper-shaped cluster. Surrounding many of those stars is a delicate haze, which is a reflection nebula made of interstellar dust that's being lit up by the cluster's intense starlight. Despite its brightness and prominence, the Pleiades is relatively young, only about 75 to 150 million years old. Over time, interactions with our galaxy will slowly disperse the cluster. However, simulations suggest it may remain coherent for another couple 100 million years. Phew. In binoculars or a wide-field telescope, M45 is a stunning sight. Its stars fill the field. I was enjoying the view recently through my 8-inch Dob with a very low-power eyepiece, and this object never gets old. It's always a joy to see, although I find it looks best in my 70mm refractor. However, with an 8-inch or larger scope under dark moonless skies, you might even trace some of the faint reflection nebulosity surrounding the cluster. It's a truly great way to start your observing session for the night. And this month, we have an additional treat when the moon will occult or appear to pass in front of the Pleiades on the evening of December 3rd. For observers in the eastern U.S., the occultation will begin a little after 8 p.m. Over the next 4 hours, you can watch the moon slowly glide past the northern section of the cluster. Around 8:43 p.m., magnitude 3.7 Electra will be covered and will reemerge about 25 minutes later. While waiting for that, you can watch magnitude 4.3 Taygeta duck behind the moon at around 8:47. At around 9 p.m., Maya at magnitude 3.8 will be covered as well. If your skies are clear, I urge you to check this out. It should be fun to watch. Next on our deep sky tour is the Hyades, one of the most important and fascinating open clusters in the sky. Located right in Taurus, it actually forms the V shape that makes up the face of the bull. Although the bright red star Aldebaran sits right in that V, it's not part of the cluster. Aldebaran's much closer at only about 65 light-years, while the Hyades members lie around 153 light-years away. What makes the Hyades so special is its proximity. It's the nearest open cluster to us, which means astronomers use it as a keystone for measuring cosmic distances. The cluster has been very well studied. It contains hundreds of stars and is relatively mature, on the order of 600 to 650 million years old. Visually, the Hyades is a treat in binoculars or at low power through a telescope. Its stars form a wide, sprawling V that spans across more than 5 degrees of sky. Because of its age, several of its brightest stars have already evolved off the main sequence and become red giants. These evolved stars, combined with younger, hotter members, make for a lovely mix of colors from gold and orange to white. From an observer's perspective, the Hyades is more than just a pretty grouping of stars. It helps us study stellar evolution, dynamics, and the way that clusters disperse over time. And because it's so close, it helps us to better understand other, more distant clusters. Next on our tour is NGC 1514, which is also known as the Crystal Ball Nebula. This is a fascinating planetary nebula, not far from the border with Perseus. It was discovered by Sir William Herschel on November 13, 1790. It sits at a distance of roughly 1,500 light-years from us. But what makes NGC 1514 especially interesting is its structure. At its heart is a binary star system. One star is a hot, compact remnant, and the other is a normal giant. Over time, these two have shaped the surrounding gas and dust in dramatic ways. Infrared observations reveal a pair of dusty rings, clumpy and filamentary, forming a kind of hourglass-like structure. Thanks to JWST, we now have some of the most detailed mid-infrared images of NGC 1514. The dust rings appear as fuzzy clumps, and there are holes in the pink central emission, places where faster stellar winds seem to have punched through. Wow! When you're observing this with a telescope, it isn't the brightest target. Its visual magnitude is around 9.4, and it spans about 2.2 arc minutes. With my 8-inch Dob from a Bortle 4 location with an O3 filter, this little nebula shows as a faint mottled glow surrounding the brighter central star. You'll want at least a 6-inch scope from dark skies to try to spot this gem. Locating it is very easy. Imagine a line from magnitude 3.9 Attic to magnitude 2.85 Zeta Persei, and continue along that line for 3 degrees. You should spot an 8th magnitude star. From that star, sweep 3/4 of a degree south, and you'll spot the crystal ball. Next up is the open cluster NGC 1647, which is sometimes called the Pirate Moon Cluster. Glowing at magnitude 6.4 and spanning 3/4 of a degree, This is a fun open cluster to observe. It contains 90 stars that are around 150 million years old. Like our previous object, the Pirate Moon was also discovered by William Herschel on February 15, 1784. The cluster is about 1,800 light-years away from us. In binoculars, NGC 1647 appears as a large faint haze, roughly the size of the full moon. It's easy to miss if you're not looking for it, but once you spot it, you'll notice that soft glow standing out nicely against the background. In my 70mm refractor at 43 power, the cluster begins to resolve, with about a dozen stars popping into view, and several fainter members showing themselves with averted vision. Through my 8-inch Dob, it really comes alive. Dozens of stars scattered across the field, including a few striking red stars, that give the cluster a wonderful sense of depth. It's a joy to observe, and is one of the most often overlooked gems in Taurus. Finding it is straightforward. Start at Aldebaran and sweep about 2.5 degrees north, then drift a little more than 2 degrees east. That faint glow that you land on is NGC 1647. And while you're in the neighborhood, slide just a little over 6 degrees farther northeast, and you'll come to another pleasing open cluster, NGC 1746. This is a pretty loose, sprawling group of stars, and to the casual observer it almost feels like a random patch of distant stars. But it's still a fun target, especially for medium-power telescopes. In fact, in binoculars or a small refractor, it can look like a faint, buzzy smattering, while my 70mm refractor at 43 power resolves quite a few individual stars with a bit of effort. If you're using a larger scope, say an 8-inch Dobsonian, this cluster really comes alive. You can pull in dozens of stars, and some of the red giants stand out nicely, giving a subtle hint of color. It's right in the same neighborhood as several other open clusters, so once you're there, you may want to hop over to nearby targets. For me, going back and forth between NGC 1746 and NGC 1647 is especially rewarding because of how different they look through different instruments. If you've got some scope time and a dark or semi-dark sky, this is a cluster to be enjoyed. Okay, now let's turn our attention to one of the most studied and scientifically fascinating objects in the night sky, M1, better known as the Crab Nebula. This is not just any nebula, it's a supernova remnant. In fact, it's the remnant of a stellar explosion that was documented by naked-eye observers all the way back in the year 1054 AD. Chinese astronomers recorded a guest star so bright that it was visible during the day for several weeks. It appears quite small in our sky. Its visual magnitude is around 8.4, and its size is roughly 6 by 4 arc-minutes. The Crab is located about 6,500 light-years away from us. At its core sits the Crab Pulsar, a rapidly spinning neutron star that spins more than 30 times per second. The pulsar is what powers the nebula, energizing the surrounding gas and producing radiation across the entire spectrum, from radio waves all the way up to gamma rays. The nebula itself is still expanding, pushing material outward at incredibly high speeds, around 1,500 kilometers per second. Over the centuries, that expansion has grown what was once a supernova blast into a roughly 11 light-year wide cloud. Through my 70mm refractor, the Crab looks like a small, faint, diffuse oval patch of light. With my 8-inch SCT and a filter, the Crab appears as a misty oval that shows hints of structure. I once got to observe it with an 18-inch scope from a dark sky site, and it appeared as a very uneven glow showing some structures, hints of filaments, and wispy tendrils of gas. Finding the Crab is pretty easy. Start at 3rd magnitude Zeta Tauri and sweep 1 degree northwest, and you should spot it. Well, that wraps up this month's tour. I hope that you'll explore some of what we've gone over and that you get to enjoy what the December 2025 skies have to offer. Our next episode should be a fun one for the astrophotographers. I'm going to do a live processing video showing my workflow in PixInsight on processing a nebula. I will also make my data shareable so that you can try processing it yourself. Be sure to look for it so you can check it out. Thank you for watching, and I hope that you found it fun, informative, and inspiring. If you've got questions, feedback, or ideas for future episodes, I'd love to hear from you. You can email me at astroguypodcast@gmail.com or send a text or a voicemail to 973-404-0380. Be sure to check out the AstroGuy Podcast group on Facebook and visit our YouTube channel for past episodes, observing tips, and bonus content. If you've enjoyed this episode, please like, subscribe, comment, and share. It really helps us to reach more fellow skywatchers. Until next time, may your skies be clear, and as always, carpe noctem, seize the night. I'm Wayne Zool, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.